Welcome back to Meg Squared Physics Crash Course video.
Today, we are going to be talking about physics and an automobile accident, reconstruction, and how they relate. We'll start out by giving you an accident scenario, and then by using physics, we will figure out which driver was at fault during this accident.
So here's the scenario. A car and a truck were passing through an intersection in Jewell, New Jersey, where the two vehicles collided and went into two different directions after the collision at different speeds. At this intersection, the truck driver had a flashing yellow light, while the car driver had a flashing red light. Neither driver claims responsibility for the accident. The car driver, Mr. Alliper, claims to have made a full stop at the light before entering the intersection and that the truck driver did not slow down prior to the collision. The truck driver, Mr. Demeter, claims to have been braking before the collision and that the car driver did not stop at the flashing red light.
Based on this scenario, we are going to use physics to see which driver was at fault, or if both of them were at fault.
In order to use physics concepts and calculations in this collision, we need a solid understanding of key principles, such as forces in motion, work and energy, friction, conservation of momentum, and kinematics.
To better understand the background information of the collision, we'll bring in the Meg Squared Physics Classroom whiteboard. A force describes the interactions between objects. Forces are actions done by an agent, which is a source on an object. After impact, the forces acting on the car and truck include normal force, gravitational force, the force of friction, and the force of the car on the truck, and the force of the truck on the car. Before the collision, the force propelling the car and the truck of the velocity is determined by the thrust of the engine in each car. Friction is a reaction and is a contact force. Friction always opposes motion and often produces heat. In this collision, after the car is hit / after the impact, there's a kinetic friction between the wheels of the car and the road. Friction between the wheels and the road is important because it allows the vehicles to move without the vehicle becoming out of control. The kinetic energy of the car and of the truck are both conserved. This is due to the fact that after the collision, the objects do not stick together. They hit and move away from each other. After impact, once the objects stop due to friction, the car and the truck will both experience potential energy. The mechanical energy comes from the actual moving parts within the vehicle, which enables them to move and function. Momentum describes how much, how fast, and in what direction an object is going. The law of conservation of momentum states that in an isolated system, all the objects involved in the action, the total momentum remains constant. The car and truck impact can be described as an elastic collision because the kinetic energy is conserved before and after impact.
You hit me!
Kinematics studies motion without thinking about its causes. This includes the position, displacement, distance, velocity, etc. of an object. To understand who's at fault during this collision, each equation represented on the board will give us our answers to see, was it the car's fault or was it the truck's? And now to do some calculations.
By using all the physics concepts and equations we just talked about, we are able to determine the coefficient of kinetic friction between the tires and the road for both the car and truck, which will lead us to find the speed of each vehicle before and after the collision, which will lead us to which driver is at fault. Our givens for this scenario would be that the force required to drag a 130 Newton car tire across the pavement at a constant velocity is 100 newtons. The coefficient of friction for truck tires is 70% that of cars. We also know that before the collision, the pre-crash angle between the two vehicles' velocities was 90, and after the collision, the truck and car skidded at angles shown in the attached diagram. We also know that the distance for the car from the traffic light to the collision point was 13 meters. The car skidded a distance of 8.2 meters and the truck skidded 11 meters before stopping. We know the weight of the car is 13,600 newtons and the weight of the truck is 69,700 newtons. We know that the truck driver claims to be going 6.7 meters per second at the moment of impact. He said he had started braking. To start our calculations, we need to convert the weights of the car and truck to find their masses. Since their weight is in newtons, we divide each by 9.81 to get kilograms. As shown on the whiteboard, we found the masses of the car and truck. Next, the coefficient of kinetic friction between the tires and the road for both the car and truck can be calculated. We know that the force of friction for one car tire is 100 newtons and the normal force is 130 newtons. So by using the equation, force of friction equals coefficient of kinetic friction times force of normal, like shown, we found the coefficient of kinetic friction to be 0.769 for the car and 0.54 for the truck. In order to find the speed of each vehicle just after the collision, we first need to find their accelerations. We find acceleration by using the equation F equals ma, but before we can use that equation, we have to find F for each vehicle using the equation force of friction equals coefficient of kinetic friction times normal force. We have all the numbers to do this, so just plug it in like shown on the whiteboard. Since we found the forces, we can now plug into the equation F equals ma to find acceleration. The accelerations here are negative because this acceleration is after the collision, so this would be how fast the cars are slowing down. So now to calculate the speed after the collision, we can use kinematics. Since we know acceleration and we know final velocity is 0 and the distance the cars traveled after the collision, we can use the equation v squared equals v initial squared plus 2a delta x. Like shown on the board, we can use all of our knowns to find the initial velocity in this equation for both vehicles, which would be the speed right after the collision. So the velocity just after the collision for the truck was 10.8 meters per second and 11.12 meters per second for the car. In order to find the speed of each vehicle just before the collision, we need to use the law of conservation of momentum equation. We know that P equals mv, and we know that the sum of P initial equals the sum of P. Based on the angles formed after the collision with the two cars, we are able to interchange the velocity of the car and truck in the x and y direction with the velocity of the car times sine/cosine and the angle at which it was projected. As shown on the board, we can use the law of conservation of momentum equation along with all of our givens and factors of the triangle to figure out that the velocity of the truck before the crash was 12.54 meters per second and the velocity of the car before the crash was 12.80 meters per second.
Based on our calculations and reasoning, both the drivers are at fault. One final calculation that we conducted was the max velocity of the car if it really stopped at the light. We know that the max acceleration of the car is 3 meters per second. Initial velocity is 0, and the distance traveled is 13 meters. We can use this equation, the final velocity squared equals the initial velocity squared plus 2a, change in y, and plug in all of our givens to find the final velocity, or in this case, the max velocity of the driver the car could obtain. We found it to be 8.33 meters per second.
We know that the driver of the car is lying based on this calculation because we found that the car's actual velocity at the time just before the collision was 12.8 meters per second. Therefore, the car is at fault because he lied about stopping at the light.
We also know that the truck is at fault because he claimed to be going 6.7 meters per second through the light. In reality, with what we calculated, his actual velocity when he was going through the light was 12.54 meters per second. Therefore, the truck is at fault, so they're both at fault and they both caused the accident.
So in conclusion, both drivers lied about what happened. The calculations prove this. If they were telling the truth about their speeds and what actually happened, the cars would not have acted the same way they did after the collision. So they're both wrong and they're both at fault.
Thanks for watching. Tune in next time.
Bye!